The morning of April 27th, 1917, a solitary merchantman cuts through grey Atlantic swells 8 miles southwest of the Lizard Peninsula. Through the lens of U-20's attack periscope, Captain Lieutenant Walter Schwieger watches the vessel approach. His U-boat has already claimed 6 ships this patrol. This target should be straightforward. But something is wrong. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Schwieger adjusts the rangefinder. The ship's silhouette fragments before his eyes into a chaos of black and white bands. Diagonal stripes slice across vertical ones. False bow waves paint the hull. He tries to determine the vessel's heading. Is she steaming toward him or away? Is that her bow or her stern? His calculations, normally precise to within a few degrees, dissolve into uncertainty. The ship is SS Industry, and she's wearing something the Royal Navy calls dazzle camouflage. Within months, thousands of Allied vessels will bear these bewildering patterns. The U-boat commanders who once hunted merchant ships with mathematical precision will find themselves staring through periscopes at targets that seem to defy geometry itself. This is the story of how artists declared war on submarines, how painters became warriors, and how geometry became a weapon more effective than armor plate. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand why Norman Wilkinson invented dazzle camouflage, you must first understand what made German U-boats so terrifyingly effective. In April 1917, German submarines were sinking British merchant ships faster than they could be replaced, 8 vessels per day. More than 500 ships between February and April. Britain was losing the war not on land, but beneath the waves. The mathematics of submarine warfare demanded precision. A U-boat commander, hunting a merchant ship, needed 3 critical pieces of information: range, speed, and heading. Get any of these wrong by even a few degrees, and your torpedo would miss. Get them right, and you could sink 20,000 tons of shipping from 2,000 meters away. The tools available to U-boat commanders in 1917 represented the cutting edge of naval technology. German periscopes featured integrated rangefinders, optical devices that measured the angular height of a target. If you knew a ship's height, you could calculate its distance by measuring the angle between waterline and masthead. Coincidence rangefinders split the target's image into 2 halves. When the operator aligned these half images perfectly, the mechanism revealed the range. For heading calculations, commanders used the angle on the bow, the angle between the ship's center line and the U-boat's line of sight. Measure this angle, factor in target speed determined by stopwatch timing, add torpedo velocity, and you produced a firing solution. The entire process took perhaps 90 seconds. Miss any calculation by more than 8 to 10 degrees, and the torpedo would pass harmlessly ahead of or behind the target. This precision made U-boats extraordinarily lethal. By early 1917, Germany operated 140 submarines. They had destroyed 30% of the world's merchant fleet. 1/5 of Britain's merchant ships lay on the ocean floor. In the first 4 months of unrestricted submarine warfare, U-boats sank more than 3,700 vessels. The British Admiralty tried everything. They painted ships grey to blend with fog. They experimented with low visibility schemes. They even erected false haystacks on decks to disguise gun emplacements. Nothing worked. A merchant ship's smoke alone betrayed its presence from 20 miles away. Once spotted, camouflage meant nothing. The submarine submerged, approached, calculated, fired. Another ship sank. Traditional military thinking about camouflage had always focused on concealment. Make yourself invisible, and the enemy cannot target you. But Norman Wilkinson understood something the Admiralty did not. You cannot hide a ship at sea. The question wasn't how to make ships invisible. The question was how to make them impossible to aim at. Wilkinson was not a naval strategist. He was a marine painter and poster artist, a lieutenant commander in the Royal Naval Volunteer Reserve assigned to minesweeping patrols off Plymouth. On a weekend in spring 1917, during a fishing excursion, an idea struck him with the force of revelation. If you couldn't hide a ship, could you lie about it? Could you paint a vessel in such a way that a U-boat commander, staring through a periscope for the few precious seconds before detection, would miscalculate everything? Could patterns of violent color contrasts fragment a ship's outline so completely that determining her true course became impossible? Wilkinson returned to Devonport Dockyard and went straight to his commanding officer. The proposal he submitted was revolutionary. Paint British merchant ships, not for low visibility, but for maximum disruption. Break up the vessel's form with masses of strongly contrasted color. Make it impossible for a submarine officer to decide the exact course of the ship he intended to attack. The Admiralty initially dismissed the idea as artistic eccentricity. Then Wilkinson demonstrated his concept using wooden models and a periscope. He painted small-scale ships in wild geometric patterns, diagonal stripes, intersecting vertical ones, false bow waves, counterfeit waterlines, zebra-like bands in black and white. He mounted these models on a rotating platform and invited senior officers to observe them through an actual periscope under different lighting conditions. The results were striking. Experienced naval officers who could normally identify a ship's type and heading at a glance found themselves completely baffled. Ships appeared to be travelling in one direction when they were actually moving in another. Bows looked like sterns. Sterns resembled bows. Distance estimates varied wildly. In October 1917, King George V visited Wilkinson's demonstration theatre. The King, a career naval officer with decades of experience, stared through the periscope at a model painted in dazzle patterns. He announced confidently that the vessel was steaming south by west. Wilkinson informed him that the ship was actually travelling east by southeast. The monarch was stunned. "I have been a professional sailor for many years," he reportedly said, "and I would not have believed I could have been so deceived in my estimate." The Admiralty authorised immediate implementation. In June 1917, Wilkinson took command of the Dazzle section, headquartered in 5 basement studios at the Royal Academy of Arts in Piccadilly. The location was appropriate. What Wilkinson was creating wasn't military camouflage in any conventional sense. It was applied geometry, optical disruption, weaponized art. He recruited a team of 19 specialists, 5 artists, 3 model makers, and 11 female art students from colleges across Britain. One of these women, Evelyn Mackenzie, would later become his wife and a crucial figure in the department's operations. The team also included Edward Wadsworth, a vorticist painter whose avant-garde aesthetic would prove perfectly suited to dazzle design. The work process was meticulous. Artists first created designs on paper, using basic geometric principles, but avoiding any standardization. Each pattern had to be unique. If U-boat commanders learned to recognize standard dazzle schemes, the advantage would vanish. Model makers then transferred these designs to wooden ship models at approximately 1 inch to the foot scale. The models were painted, mounted on rotating platforms, and tested under various lighting conditions using actual submarine periscopes. Wilkinson and his team viewed each model through periscopes against different backgrounds: grey skies, stormy seas, dawn light, dusk conditions. They simulated the exact visual environment a U-boat commander would experience. Only designs that successfully confused experienced observers were approved for production. Once approved, female workers hand-coloured technical plan sheets with precise instructions. These plans were copied and dispatched to British ports, where dazzle officers supervised the actual painting of ships. A secret handbook assisted port officers in translating the complex geometric schemes onto hulls, superstructures, and smokestacks. The designs themselves defied description. Violently contrasting colours, black against white, blue against grey, were contained within arcing curves, diagonal slashes, and zigzag lines. Some patterns resembled saw teeth, inspired by Wilkinson's observation of a bucket dredger. Others featured checkerboard designs or vivid stripes that seemed to vibrate when viewed through a lens. False bow waves, painted midship, suggested the vessel was travelling faster than her actual speed. Counterfeit waterlines, positioned above or below the true waterline, distorted range calculations. Vertical lines broke horizontal ones. Curves intersected diagonals. Every accepted form that identified a ship's type and heading was deliberately shattered. The first vessel to receive Dazzle treatment was SS Industry, a small store ship painted in May 1917. Coast guards and other ships sailing British waters were asked to report observations when they encountered her. The reports flooded in. Observers were confused about Industry's heading, her speed, even her size. Some thought she was travelling toward them when she was actually steaming away. Others misjudged her distance by 50% or more. By October 1917, enough evidence had accumulated. The Admiralty ordered all British merchant ships to receive Dazzle treatment. The order represented an unprecedented industrial undertaking. More than 4,000 British merchant vessels would eventually be dazzled, along with approximately 400 naval ships. Every pattern was different, every design was unique. The science behind Dazzle was both simple and sophisticated. U-boat periscope rangefinders worked by splitting a target's image. The operator rotated a prism until two images, one above the other, aligned perfectly. When the waterline of the upper image touched the masthead of the lower image, the mechanism displayed the range. But what if you couldn't identify the waterline? What if false structural lines made perfect alignment impossible? Dazzle patterns attacked this optical process. Painted waterlines appeared at wrong heights. False deck lines suggested incorrect vessel proportions. The human eye and brain, trying to make sense of the fragmented image, would struggle to determine which lines were real and which were painted deception. Heading calculations were even more vulnerable. To determine a ship's course, a U-boat commander measured the angle on the bow, the angle between the vessel's centerline and the submarine's line of sight. This required identifying which end of the ship was which. Dazzle patterns made this determination extraordinarily difficult. A false bow wave painted amidships suggested the vessel's bow was elsewhere. Diagonal stripes running from upper deck to lower hull created the illusion that the ship's fore and aft axis ran in a completely different direction. Vertical patterns broke up the horizontal lines that normally revealed hull orientation. The U-boat commander, with perhaps 60 seconds of periscope observation before risking detection, had to sort real geometry from painted lies. The margin for error was razor thin. German torpedoes of 1917 required precise heading calculations. A torpedo, fired from 2,000 meters with even an 8-degree error in heading, would miss its target entirely. Dazzle didn't need to conceal ships. It only needed to introduce that 8 degrees of uncertainty into the U-boat commander's calculations. The patterns also played havoc with speed estimation. Submarines calculated target speed by timing how long a vessel took to travel a known distance. But if you couldn't accurately determine heading, you couldn't accurately measure distance traveled. A ship painted in Dazzle might appear to be moving slowly when actually steaming at full speed, or vice versa. False bow waves compounded the confusion, suggesting higher speeds than the vessel was actually achieving. American naval observers who witnessed Dazzle's development described it as visual warfare. The patterns didn't just confuse the eye, they confused the brain's pattern recognition systems. Human visual processing relies on detecting edges, identifying symmetries, and extrapolating shapes. Dazzle deliberately violated all these cognitive shortcuts. In March 1918, at the request of the United States government, Norman Wilkinson sailed to Washington. America had entered the war in April 1917, and U-boats were now targeting American merchant ships with devastating effect. Wilkinson met with Secretary of the Navy Franklin Delano Roosevelt and helped establish an American Dazzle unit. The American unit was headed by Impressionist painter Everett Warner, with architects Harold Van Buskirk and physicist Lloyd Jones. They set up operations similar to Wilkinson's London facility, complete with model ships, periscopes, and testing theatres. American designers created over 1,000 Dazzle schemes, though none precisely copied British patterns. Maintaining uniqueness was essential to the system's effectiveness. Artists like Thomas Hart, Benton, and other prominent American painters joined the camouflage unit. The work appealed to avant-garde sensibilities. These patterns resembled cubist paintings or vorticist compositions. They had the visual impact of modernist art movements, but they were designed with lethal purpose. deceive enemy calculations, save Allied lives. The scale of Dazzle implementation was extraordinary. By mid-1918, more than 2,300 British ships had been dazzled. The United States Navy reported painting over 1,200 vessels. France established its own Dazzle section in Paris after sending 4 officers to study with Wilkinson. Italy adopted British plans. Allied navies worldwide implemented the system. The painting process itself was labor-intensive. Each vessel required custom application based on approved plans. Ships in dry dock were painted by teams of workers who transformed grey hulls into geometric spectacles. The paint itself was standard maritime coating oil-based with high-gloss finish, but the application required precision. Lines had to be sharp. Color contrasts had to be maximized. False structural elements had to appear convincing. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The patterns were deliberately startling. Sailors initially hated them. The designs made ships conspicuous in ways that violated every instinct about camouflage. Traditional military thinking associated camouflage with blending in. With invisibility, Dazzle did the opposite. It made ships stunningly, flamboyantly visible. But visibility wasn't the issue. Detection wasn't the problem U-boats were trying to solve. German submarines located targets by smoke plumes visible from 20 miles away, or by wireless intercepts revealing convoy routes, or by patient waiting along shipping lanes. Once located, a target's visibility meant nothing. What mattered was whether the U-boat commander could aim accurately enough to sink it. Reports from merchant captains began filtering back to the Admiralty. The testimonies were remarkably consistent. U-boat attacks against dazzled ships showed unusual patterns. Torpedoes were passing ahead of vessels when calculations suggested they should hit amidships. Others were passing astern when targeting solutions indicated direct hits. The torpedoes weren't malfunctioning. The calculations were wrong. German naval intelligence noticed. In 1920, Wilkinson reported that a surrendered U-boat officer had stated the German Admiralty dazzled a liner and attached it to the submarine training depot at Kiel. They were trying to understand how British camouflage was defeating their targeting systems. Several surrendered submarines had been painted in patterns precisely matching British merchant vessels, evidence that Germany took Dazzle seriously enough to study it intensively. The statistical evidence proved challenging to evaluate. The Admiralty's Committee on Dazzle Painting reported in September 1918 that there was no clear statistical proof that Dazzle confused submarine gunners. However, the report noted something crucial. Dazzle painting had caused an undoubted increase in the confidence and morale of officers and crews of the mercantile marine. This psychological factor alone might have justified the program's cost, but American statistics told a different story. Between March 1st and November 11th, 1918, the U.S. Navy reported that of 1,256 merchant ships painted in Dazzle, only 96 were sunk, approximately 7.6%. More tellingly, U.S. sources claimed that none of the Dazzle-painted fighting ships were torpedoed during this period. The numbers suggested real protective value. The truth likely lay between these positions. Dazzle didn't make ships invulnerable. It introduced enough uncertainty into targeting calculations to significantly reduce hit probability. When, combined with convoy tactics, groups of merchant ships sailing together under escort, Dazzle's defensive value multiplied. A U-boat commander who might have time to attack multiple ships in a convoy would waste precious seconds on each one trying to establish accurate targeting data. The effectiveness of Dazzle camouflage ultimately depended on a fundamental asymmetry in submarine warfare: time. A U-boat commander had perhaps 90 seconds of periscope observation before the risk of detection became unacceptable. Every second the periscope remained raised increased the chance that lookouts would spot the telltale feather of water, that escorts would alter course toward the submarine, that the hunter would become the hunted. Those 90 seconds had to accomplish everything: identify the target, estimate range using the periscope rangefinder, Determine heading by measuring angle on the bow. Calculate target speed through timed observations. Factor in torpedo velocity and running distance. Solve the geometric triangle that would place a torpedo in the same position as the target ship at the same moment in time. Then transmit the firing solution to the torpedo room, set gyroscope angles, and give the order to fire. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Dazzle attacked every stage of this process. The rangefinder measurement required identifying a ship's waterline and masthead. Dazzle painted false waterlines and broke up vertical structures. Heading determination required distinguishing bow from stern and identifying the vessel's centerline. Dazzle created false bows, counterfeit structural lines, and geometric chaos that obscured the true axis. Speed calculation required accurate heading data. If heading was wrong, speed estimates became worthless. The cumulative effect was devastating. A U-boat commander who might normally need 30 seconds to establish a firing solution found himself spending 60 or 70 seconds still uncertain about basic parameters. And time was the one resource submarines couldn't afford to waste. Every additional second of periscope observation increased vulnerability. Some U-boat commanders, faced with dazzle-painted targets and dwindling time, simply chose not to attack. The uncertainty wasn't worth the risk. German submarine doctrine emphasized conserving torpedoes. Each U-boat carried between 12 and 16 torpedoes depending on type. Expending one on a target you weren't confident of hitting represented potential waste of a scarce resource. If Dazzle introduced enough doubt to make commanders hesitate, it succeeded even without preventing successful attacks. Deterrence through confusion proved as valuable as actual protection. The psychological impact on submarine crews was significant. U-boat service was already extraordinarily dangerous. 54% of German submarines were lost during the war, 202 boats out of 375 deployed. Of 17,000 sailors who served in U-boats, approximately 5,000 died. The men who survived faced constant stress, claustrophobic conditions, and the knowledge that every patrol might be their last. Now they faced targets that seemed to defy optical physics, ships that appeared to steam in one direction while actually moving in another, vessels whose speed seemed impossible to gauge, hulls painted in patterns that seemed designed specifically to exploit the limitations of periscope optics. The cumulative stress of hunting targets you couldn't accurately aim at took psychological toll. Several U-boat commanders reported that attacking dazzled ships felt like firing blind. The convoy system, implemented in May 1917 around the same time Dazzle deployment accelerated, proved the decisive factor in defeating the U-boat threat. Merchant ships sailing in groups, protected by destroyer escorts, reduced the window of vulnerability. A submarine attacking a convoy risked immediate counterattack. Depth charges, introduced in 1916 and refined throughout 1917, gave escorts effective weapons against submerged U-boats. But Dazzle and convoys worked synergistically. A U-boat commander attempting to attack a convoy had limited time before escorts detected and engaged him. Dazzle patterns extended the time needed to establish targeting solutions. This combination reduced attack time, plus increased calculation time, created a defensive advantage that significantly reduced successful torpedo strikes. By November 1918, when the war ended, Allied shipping losses had dropped dramatically from their April 1917 peak. Multiple factors contributed: increased destroyer production, improved depth charge technology, aerial patrols, convoy tactics, and Dazzle camouflage. Separating Dazzle's specific contribution from these other variables proved impossible. But the testimony of U-boat commanders and the statistical evidence from American naval operations suggested real defensive value. The artistic legacy of Dazzle proved as significant as its military impact. Edward Wadsworth, the vorticist painter who supervised Dazzle painting in Liverpool, created a series of stark black and white woodcuts depicting Dazzle ships. These images, exhibited after the war, brought Dazzle patterns into fine art galleries. Wadsworth's work inspired discussions about whether military camouflage could be considered art and whether artists working on Dazzle were creating functional design or aesthetic statements. The debate reflected deeper questions about the relationship between art and warfare. Norman Wilkinson was an artist who invented a weapons system. His Dazzle patterns employed principles of visual disruption that paralleled avant-garde art movements like Cubism and Vorticism, yet they were designed to save lives by confusing enemy calculations. The boundary between aesthetic innovation and military technology dissolved completely. Pablo Picasso, upon seeing a cannon painted in Dazzle patterns being transported through Paris streets, allegedly claimed credit for the invention. "Yes," he reportedly said, "it is we who made it. That is Cubism." The comment, whether apocryphal or not, highlighted the visual kinship between Dazzle and modernist painting. Both sought to fragment perception, to challenge conventional ways of seeing, to make viewers question their visual assumptions. But where Cubist paintings aimed to provoke intellectual reflection, Dazzle patterns aimed to provoke fatal miscalculation. The visual disruption served lethal purpose. Every line, every color contrast, every geometric intersection was positioned to maximize confusion in the mind of a U-boat commander with seconds to decide. Art became weaponized geometry. The development process itself revealed how artists approached military problems differently than engineers. Engineers might have sought to measure Dazzle's effectiveness through controlled experiments and statistical analysis. Artists instead relied on perceptual testing, on subjective observation, on understanding how human visual processing could be exploited. Wilkinson's method was empirical but not quantitative. If experienced observers were confused, the design worked. This approach frustrated military planners who wanted definitive proof of effectiveness. How many ships had been saved by Dazzle? What percentage of torpedo attacks had missed because of camouflage? These questions couldn't be answered with precision. You couldn't know which torpedo misses resulted from Dazzle confusion versus mechanical malfunction, navigational error, or random chance. The absence of clear statistical validation made some Admiralty officials skeptical, yet the program continued and expanded. The Admiralty's September 1918 report acknowledged that statistics didn't prove Dazzle's effectiveness, but it noted the massive boost to morale among merchant crews. Sailors who felt they had some protection against U-boats sailed with greater confidence. That psychological factor alone justified the relatively small cost of paint and labor, and if Dazzle actually prevented even a small percentage of successful torpedo strikes, the return on investment was enormous. The cost calculation was straightforward. Painting a merchant ship in Dazzle patterns required perhaps 1 week's work by a team of painters, consuming several barrels of standard marine paint. The total cost per vessel was perhaps £200 sterling. Compare this to the value of a merchant ship, tens of thousands of pounds plus cargo value, potentially hundreds of thousands of pounds plus the lives of crew members, priceless. Even a small reduction in loss probability represented tremendous value. Individual ships reported remarkable survivals. Numerous merchant captains testified that torpedoes had passed ahead of or behind their vessels during attacks, missing by margins that suggested targeting errors rather than mechanical failures. One captain reported watching a torpedo's wake pass 30 feet ahead of his dazzled ship's bow, exactly where calculations would have placed it if the U-boat commander had misjudged heading by approximately 10 degrees. The dazzle patterns had potentially introduced precisely that margin of error. The German perspective on Dazzle's effectiveness remains partially obscured. German naval records from the war's final year are incomplete, and U-boat commanders had little incentive to report that enemy camouflage was confusing their targeting. But post-war testimony from captured submarine officers consistently acknowledged that dazzled ships presented targeting difficulties. The patterns didn't make attacks impossible, but they made accurate attacks significantly harder. One German commander described the experience of attacking a dazzled merchant ship as trying to aim at a ship that seemed to be traveling in 3 directions simultaneously. Another noted that dazzle patterns transformed what should have been simple geometry into optical riddles. These testimonies, recorded by Allied intelligence officers, suggested that Dazzle achieved exactly what Wilkinson intended. It didn't hide ships, but it made them extraordinarily difficult to aim at accurately. The technical limitations of World War I submarine technology made Dazzle particularly effective. Later developments, more sophisticated rangefinders, longer periscope observation times made possible by better detection, evasion, and eventually radar would reduce Dazzle's utility. But in 1917 and 1918, when submarine warfare relied on optical observation through primitive periscopes and manual calculation of targeting solutions, Dazzle exploited precisely the right vulnerabilities. By war's end, Dazzle had become ubiquitous across Allied navies. More than 6,000 ships had been painted in disruptive patterns. Thousands of artists, painters, and workers had contributed to the effort. The visual landscape of naval warfare had transformed completely. Where once merchant ships sailed in sober greys and blacks, now they cut through Atlantic swells, wearing geometric patterns that seemed torn from avant-garde art studios. The transformation was total and temporary. After November 1918, most Dazzle patterns disappeared beneath fresh coats of conventional paint. Ships required regular repainting for maintenance, and peacetime economics favored simple schemes over complex patterns. Within 2 years, the Dazzle phenomenon had largely vanished from the seas. The visual spectacle that had defined Allied shipping during the war's final 18 months became a historical curiosity. World War II saw limited revival of Dazzle. The Royal Navy experimented with updated patterns in 1940, particularly the Western Approaches schemes designed by wildlife artist Peter Scott. American naval vessels employed modified Dazzle during 1942 and 1943, but advancing technology radar, improved sonar, aircraft reconnaissance made optical camouflage increasingly irrelevant. Dazzle belonged to an era when submarine warfare depended on human eyes, optical instruments, and manual calculations. The legacy persisted in unexpected ways. Military camouflage designers studying Dazzle's principles recognized broader applications. Disruptive patterning using contrasting colors and geometric shapes to confuse visual perception became foundational to modern camouflage theory. The Dazzle concept influenced vehicle camouflage, aircraft markings, and eventually the digital camouflage patterns used on contemporary military uniforms. The idea that camouflage could confuse rather than conceal represented paradigm shift. Traditional camouflage sought invisibility through background matching. Dazzle proved that visibility didn't equal vulnerability if the visible image contained false information. This principle, deceive perception rather than avoid it, became central to modern information warfare, electronic countermeasures, and cyber defense strategies. The conceptual leap Wilkinson made in 1917 continues influencing military thinking more than a century later. Norman Wilkinson himself received formal recognition. The Royal Commission on Awards to Inventors declared him the official inventor of Dazzle camouflage after contentious proceedings where zoologist John Graham Kerr claimed prior development of similar concepts. Wilkinson received monetary compensation of £2,000, sterling significant but hardly proportionate to the potential value of ships and lives his invention may have saved. He continued his art career after the war, creating marine paintings, poster designs, and illustrations. During World War II, he worked for the British Air Ministry on airfield camouflage, applying similar deceptive principles to concealing installations from aerial observation. He died in 1971, having witnessed Dazzle's transformation from military necessity to historical footnote to artistic inspiration. The question that haunted the Admiralty throughout 1918 and continues to fascinate historians today is deceptively simple. Did Dazzle camouflage actually work? The answer depends entirely on what work means. If effectiveness is measured purely by statistical reduction in ship losses, the evidence remains frustratingly ambiguous. The British Admiralty's own Committee on Dazzle Painting concluded in September 1918 that clear statistical proof of confusion among submarine gunners did not exist. Too many variables affected survival rates: convoy tactics, destroyer escorts, improved depth charges, aerial patrols, declining German submarine effectiveness as Allied countermeasures improved. Isolating, Dazzle's specific contribution proved mathematically impossible. Yet the American experience suggested different conclusions. United States Navy data indicated that between March and November 1918, of 1,256 Dazzle-painted merchant ships, only 96 were sunk, 7.6%. More remarkably, American sources claimed 0 Dazzle-painted fighting ships were torpedoed during this period. These numbers, if accurate, implied substantial protective value. The discrepancy between British skepticism and American confidence likely reflected different operational contexts. British merchant ships faced more concentrated U-boat attacks in waters closer to German bases. American vessels often operated in areas where submarine presence was lighter. The statistical samples weren't comparable, but even accounting for these differences, the American figures suggested Dazzle provided measurable benefit. Individual testimonies filled gaps that statistics couldn't address. Merchant captains consistently reported torpedoes missing their vessels by margins, suggesting targeting errors rather than mechanical failures. U-boat commanders acknowledged privately that dazzled ships presented exceptional difficulties. One German officer, interrogated after capture, stated bluntly that attacking dazzle-painted targets required twice the normal observation time to establish confident firing solutions. In submarine warfare, where every second of periscope exposure increased detection risk, doubling targeting time represented critical disadvantage. The morale factor proved equally significant. Merchant seamen sailing dazzled ships reported feeling less vulnerable, more confident, more willing to sail dangerous routes. This psychological effect translated into operational advantage. Ships with confident crews sailed more efficiently, maintained better discipline during attacks, and recovered more quickly from near misses. The Admiralty's report specifically noted this undoubted increase in confidence and morale as justification for continuing the program even absent definitive statistical proof. Perhaps the most telling evidence came from Germany itself. Captured U-boats bore dazzle patterns matching British merchant ship designs. The German Admiralty had dazzled a liner and assigned it to the submarine training depot at Kiel, using it to train commanders in attacking camouflaged targets. Germany wouldn't have invested resources in countering dazzle if it considered the technique ineffective. The enemy's response validated what statistics couldn't conclusively prove. The true measure of dazzle's effectiveness may be conceptual rather than statistical. Norman Wilkinson fundamentally changed how naval warfare thought about camouflage. Before dazzle, military camouflage meant concealment, making targets invisible or undetectable. Wilkinson proved that camouflage could mean deception, making targets impossible to aim at accurately even when fully visible. This conceptual revolution influenced military thinking far beyond World War I naval operations. Modern stealth technology employs similar principles. Stealth aircraft don't seek invisibility, they seek to confuse radar systems about location, heading, and speed. Electronic warfare doesn't prevent detection, it introduces false information that makes accurate targeting impossible. Cyber defense doesn't hide networks, it creates deceptive architectures that misdirect attackers. All these strategies descend conceptually from Wilkinson's insight. Confusion can be more valuable than concealment. The artistic legacy proved equally enduring. Dazzle patterns influenced modernist art movements, graphic design, and visual culture throughout the 20th century. The bold geometric patterns appeared in fashion, architecture, and commercial art. Contemporary artists continue creating works inspired by dazzle, exploring themes of perception, deception, and the aestheticization of warfare. Museums mount exhibitions examining dazzle's dual nature as functional military technology and compelling visual art. In 2021, the Royal Navy dazzle-painted HMS Tamar, making it the first British warship since World War II to feature the distinctive patterns. The decision was ceremonial rather than functional. Modern naval warfare makes optical camouflage largely obsolete, but the revival acknowledged dazzle's historical significance and continued cultural resonance. The patterns that once confused U-boat commanders now serve as floating monuments to innovation born from desperate necessity. Several cities maintain dazzle commemorations. Liverpool, where Edward Wadsworth supervised painting of thousands of ships, hosts annual Dazzle festivals. Ferries on the River Mersey occasionally receive temporary dazzle schemes designed by contemporary artists. These celebrations honor not just a camouflage technique, but a moment when artists became warriors, when painters wielded brushes as weapons, when aesthetic innovation served lethal purpose. The ships themselves have vanished. Time, weather, and peacetime repainting erased virtually every original dazzle pattern. A few photographs survive, mostly taken in port or during trials. These images provide our only direct visual evidence of how dazzle patterns appeared on actual vessels at sea. The photographs cannot capture what U-boat commanders saw, the fragmentary, confusing images visible through primitive periscopes under combat conditions. That experience died with the men who lived it. What remains is the idea that visibility doesn't equal vulnerability if the visible contains lies, that geometry can be weaponized, that artists possess unique capabilities for solving military problems, that confusion can save lives as effectively as armor, that human perception is exploitable, that optical systems have limitations, that time pressure creates decision-making vulnerabilities. Norman Wilkinson's dazzle camouflage succeeded not because it made ships invisible, but because it made them incomprehensible. In those critical seconds, when U-boat commanders needed certainty, dazzle provided chaos. In the narrow window, when targeting solutions demanded precision, dazzle introduced doubt. Ships painted in dazzle patterns didn't hide, they lied. And in naval warfare, where mathematics determined survival, lies proved as protective as steel. The story of dazzle camouflage ultimately transcends questions of statistical effectiveness. It represents human ingenuity, confronting technological threat. It demonstrates how unconventional thinking can solve problems that defeat traditional approaches. It proves that warfare, despite its terrible purpose, sometimes generates innovation with lasting value beyond the battlefield. Those wild geometric patterns that confused German submarine commanders in 1917 continue teaching lessons about perception, deception, and the power of visual information to shape reality itself. The ships are gone. The patterns have faded. But the idea endures. Sometimes the best defense isn't hiding from your enemy. Sometimes the best defense is making your enemy see lies when they look at truth. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.